All right.
Windows, and it didn't work too great.
Another topic that people don't understand is Keyspace. So if I told you I'm going to encrypt them with 1024-bit encryption, is that good or bad?
I can't honestly say.
4096 is out. So if 4096 is available, is 1024 good enough? Well, we're going to find out. Okay. If I give you one lock and one key, could you unlock that? It is the correct key, by the way. It is the correct key. Obviously, no brainer. You put the key in, open the lock. Easy enough. Now, what if I give you two keys and only one of them is the correct key? Could you still do it? So our key space here is 2. I'm going to try one, didn't work, try the other. I watched the show Amazing Race. I don't know if you've ever seen that show. Was it a season or two ago where they had this entire ring of keys and they had to unlock all these locks? Same kind of thing. Okay. Now what if I give you 3 keys? Would it take me longer? I possibly could get it on the first shot. Or the second shot. Or I might even take all 3. So you can see how, so we have a key space now of 3, it's taking longer. How about 4? We can still do it. But now it's going to take 4 times as long on the average than it would with only 1 key. How about 5? Or 10? How about 50 keys? Could we do it with 50 keys? Take a while. So if you are, in my office, I literally have 50 locks right now. If I gave you 1 key, could you unlock, find out which lock it goes to? Yes, it might take you a while. So if I was using that to protect something, would this be a good option? First of all, what am I protecting? If I'm protecting a donut, I don't like donuts, so we're good. But it really depends on what you're protecting. Okay. So let's go back to binary for a second. This is binary. You should have learned binary in at least one of your classes. Binary, we have 2 digits, a 0 and a 1. That's it. So 1 is a 1, a 2. So basically when we reach the highest number, we increment the next one. Kind of like in decimal when we count to 10. We start at 0, we get up to 9, we're at the highest number. So the 9 changes to a 0, we increment the next number to a 10. When we get to 19, we're at the highest number. So the 9 becomes a 0, we increment the next number. We get to 99, they're both at the highest number, so we switch both of them to 0, increment the next number. Same in decimal. You get to the highest number, which is a 1. Change it to a 0, increment the next number. That's for 2. Now we have 1, 0, which is 2. Then we change the 0 to a 1. That's 3. They're both at the highest number, so we change both of them to a 0, increment the next number. That's 4. It's exactly like we do in decimal, but in decimal we have to worry about 10 numbers, in binary we have to worry about 2. Has anyone ever driven in Europe? One of us. Okay. I spent like 7 years over there. Metric system. Everything's in liters. Everything's in kilometers. How long do you think it took me to learn the whole liters and kilometers thing?
Probably not too long. A couple weeks because you were saturated with it.
I would say probably a day or 2. Because, I mean, you're there. I went to Spain 3 years ago with Virginia. And she had never spoken Spanish, never been there. But literally, we were there. We got there in the afternoon. Spent the rest of that day. We basically slept. We were tired. We had the entire next day. Then we left at noon on the 3rd day. By the end of the 2nd day, she was already ordering drinks. She could order basic food. And it kind of upset her because everybody looks at you and they speak English to you. So it's like kind of depressing. You go there, expect to order 2 beers, dos cervezas, por favor. And they're like, you want a beer? She's like, well, that sucks. But the point is, binary is easier. We're just not used to it. Which really sucks. Okay? I don't know how you can't see those yet. Somehow I hit the wrong button. Okay.
I always got numbers, but the part that always confused me was once they started getting them into letters.
Oh, like hexadecimal?
Yeah.
Well, with hexadecimal, we got up to 9. That's our highest number. We need 16.
Oh, no,
So then we start with
I'm
A.
not talking about hex. I'm talking about taking binary and getting a readable message.
Oh, well, that's ASCII character, stuff like that. So, all right. So, 2 to the 1 is 2 possibilities. Okay, 1 or 0. Okay, 2 to the 4th, I'm sorry, not 2 squared is 4 possibilities. 2 squared is 2 times 2. Those are the possibilities of 2 squared. There's 2 to the 3rd, or 2 cubed. You see, those are all the possibilities. So you're seeing exactly how many possibilities we have. Okay. So 2 to the 4th, 16 possibilities, and there's all the combinations of them. There's no other combination. Okay. So 2 to the 8th will give us 256-bit. 2 to the 25th will give us that many. So, we talk about how many keys. Is a 25-bit system enough? Look how many different keys there are for 25-bit.
That's all there is.
But that's still quite a few.
Yeah, it's still quite a few.
The problem is now we got computers that can literally check millions of them per second. So, okay, so we're checking millions per second. So we got 100. So this is 33 million. So if we're checking a million per second, this will only take 33 seconds. Okay?
Now, question though.
What?
Physically, I think it would be easy to implement, but for this, would there be a way to implement a second lock that only one of them actually works? Double the trial time because it has to try and want both locks, but only one of them.
That's kind of like saying this message, there's 2 different pieces of ciphertext, but only one of them is correct. You could do that, but now I'm having to generate 2 of them, and I'm going to have to keep track of which one's correct.
Okay.
So when I send them to you, then you're, in case those listening on the recording, it's actually a great question. Rather than just making more keys, what if we made more locks? Again, if I'm making 2 pieces of ciphertext now, and if you remember the steganography video in forensics, where basically it says flee, but the message said come until I get you. Isn't that this week? It's this week.
You mentioned it at some point.
Yeah, it's in this week's recording. But for whoever the guy is, baking somebody, not Mavis Bacon, whatever, but he sent a message that says, stay until I come and get you. But he actually changed the format of some of the letters. If you read only the letters with the different format, it said flee. Basically, it was a message encoded in a message. Which one do you understand? Which one do you follow? So, okay. So 25-bit, that's quite a few. But we just saw that if we have a computer, they can do a million per second. We're talking 33 seconds. How about 40-bit? That's a lot of seconds. Because if I did, there's thousands. So the 1 is the first of the million. So that's 1,099,511,000,000. So if I'm doing a million per second, that's a million millions. Wow. A million seconds then. If I'm doing a million a second, then that's a million seconds. So it's quite a bit of time. Okay, how about if I went 56-bit encryption? That's what DES is. Is that enough keys? Are we happy with 56-bit? Okay, last week they showed the unveiling of the iPhone 7. So it keeps getting faster, it keeps getting better, and now they keep increasing the storage. What do you all have for storage on your phones? I have 128 gig.
I think mine is 32.
Yeah, 32. I got the 128 gig because it was available. Okay?
Feels like just as fast as the other.
And I'm going to go in here real quick. Shouldn't I be able? Okay. My OS capacity, in other words, after the operating system, is 113 gigs. So they used a little bit for the operating system. I still have 68 gigs available. So why did I upgrade to 128-bit? Literally 64 would have been perfect. Okay. So is 56-bit keys enough? What am I protecting? So if I had to pay more money, like right now with PGP, I can get a 2048-bit key for free. Have to pay money if I want the 4096. Let's look how big 2048 is. There's 128-bit. There's 256-bit. There's 1024-bit. There's 2048-bit encryption. I can get that for free. What do you think? Oh, I don't have the next one on there. See the difference between there and there? Well, double that one as much. So, is a 2048 enough? Some people say no.
Well, if we can go higher, then obviously.
But do we need to?
No, it's not about need. It's about can you.
It's want. Did I need 128-bit? Do I need a new phone? No. Do I need a new car? No. I was actually driving the other day. I bought my car. It's a 2012 model. Bought it in 2011. It's basically 5 years old. Other than my Prius, that's the longest I've ever owned a car. So should I buy a new one?
Is it still working?
Not a problem with it. Not a single problem with it. But there's a newer one out there.
So,
There's a better encryption key out there. 4096 is available. See what my point is? Do you need it? I mean, yeah, it's going to be harder to break, but what are you protecting? You know, if I'm storing the password to the dog food container, you know, I got a safe at home. A nice safe. I bought it. Okay, why do you think I bought the safe? Anyone got an idea?
well, based on previous statements, to store dog food.
I actually bought it to store batteries. How many of you got young kids? Anybody? No one has young kids in here?
Well, I am the young kid.
Well, okay. When I had young kids, I mean, everything had batteries in it. Everything. Remote controls, everything had batteries. And I swear I'd buy a box of batteries and they were gone. My kids would eat them, I think. All the remotes, the backs were lost. And I swear daily they needed new remote batteries. So I got so tired of buying batteries, I bought a safe to store the batteries in. They lasted so much longer because they would literally disappear. So, yeah, I store other stuff in there too. But the point is, how much encryption is enough? So if you had a choice today of 2048 or 4096, if they were both free, what would you go with? 4096, it's free. What if you had to pay a nickel? How about a dime? See, at what point is it not worth it to you?
See, you've already lost me because of the hassle it would take to pay the money.
That's
Because
an
most
issue.
likely I'm buying this online,
You got to somehow get them that money. Right.
and I'm not
So-
going to go through the trouble of filling out this form if this one's enough.
Right. So it's enough today. Is it enough tomorrow? You know, Moore's law. Y'all know what Moore's law is. Every 18 months, things double in power, basically. So 2048 next year is going to look like 1024 now. A couple years from now, it's going to look like 128. Still, look at the number of keys in 128. That's a lot of possibilities. So.
Isn't that the argument to buy it then? If stuff is constantly being broke.
Exactly. That's why you would buy something better, because you're right. Things are getting faster. Things are getting broken. When I was in a class down in Houston, a guy shared a rainbow table with me. He explained what a rainbow table is. If I'm trying to break passwords, the way a password breaking tool works, in forensics you'll learn how to do this, but it calculates a hash value, then does a comparison. Just like I told you when I logged into the computer. So it's going to try A. Calculate the hash for A, compare it against my password, it's not going to match, and then it's going to go with B. And so on and so forth until whatever I tell it. Well, this guy, a rainbow table is just a collection of the hashes already calculated. So all you got to do is a comparison. So you're skipping that whole calculate the hash step. You're just, does this match? Does the next one match? Does the third one match? You keep going to the end. We had a rainbow table of every number and letter up to 12 digits long off of your keyboard. Pretty awesome. And you actually do a project in network security where you use OpCrack, and I think I put that in another class as well, where we actually use rainbow tables, and you see it breaks passwords instantly because it doesn't have to do the calculation.
You had an assignment like that in mobile device security.
Okay, I might have done it in there too. Yeah. But the whole point is, people are like, well, how long does the calculation take? Well, how long does it take you to do a calculation? If you just had to compare two numbers together or do a mathematical calculation first, which one's quicker? Just a comparison. So,
A good way to represent that. Oh, hit Control F on your keyboard.
to find, yeah.
How long does it take your computer to find a value?
Yeah. Good point. And it does take a while. So, all right, everybody okay on the whole key link thing? Because someone, there's a project you do in security commerce with PGP. And someone asked the question, hey, which one's better? Well, obviously the bigger numbers, the better. But, Cameron probably can't hear me now, but Cameron bought a new car like 2 years ago. Then they had a little bit better one, so he bought another new car. Now it went from 19 miles per gallon to 13 miles per gallon. But it's like the heavy-duty Dodge Charger, just he burns more gas starting his car than I burn in a week. But did he need it? No, but did he want it? Yeah. So, it's okay. My car is silent, and that's actually a problem. I almost run over a lot of people because my car's silent. So, all right, that's enough on Keyspace.